Imagine stepping outside on a clear dark night and looking up at the glittering expanse of the cosmos. Every single star, every glowing nebula, and every distant galaxy you can perceive is nothing more than a fraction of the universe's true reality. For decades, there has been a silent operator lurking entirely in the shadows of the universe, operating completely undetected by human eyes. This invisible architect fundamentally holds our models of the cosmos together, yet we have spent nearly a century without a single clue as to what it actually is. Physicists across the globe have dedicated their entire lives to hunting it, deploying state-of-the-art particle accelerators, burying laboratories deep underground, and pointing our most powerful telescopes at the heavens, all in a desperate attempt to find direct evidence of this elusive substance. But year after year, decade after decade, the result was always exactly the same: zero success. That is, until a massive breakthrough shattered the silence. In November 2025, a stunning discovery rocked the scientific community to its core, revealing a telltale signature coming from deep inside our very own Milky Way. A 90-year-old cosmological cold case may have finally been solved, and we are about to look at the undeniable proof. To understand the sheer magnitude of what was just found, you have to fundamentally change the way you view everything around you. Look at your hands, the earth beneath your feet, and the brilliant sun in our sky. All of this is made of regular matter. But in the grand cosmic scale, regular matter is a profound anomaly. The staggering truth is that there is 6 times more of this mysterious, unknown substance out there than there is of the regular matter that makes up you and me. This dark matter makes up more than 80% of all the matter we know of in existence, completely dominating the gravitational landscape of reality. It is the invisible scaffolding that dictated the formation of the very first baby stars and galaxies at the cosmic dawn. It has sculpted our cosmos to look the exact way it does today, and its relentless gravitational influence will undoubtedly dictate the ultimate fate of our future. Yet, despite its overwhelming abundance and vital structural importance, it possesses a deeply terrifying property. Dark matter earned its ominous name because of its very nature. It is a substance that absolutely refuses to interact with light. This presents a catastrophic problem for astronomers and physicists. For all of human history, light has been the primary tool we use to probe our universe and understand how it works, from the microscopic quantum realm to macroscopic galactic scales. We analyse starlight to determine what distant planets are made of, and we capture ancient photons to look back in time. But dark matter completely bypasses this fundamental mechanism. It does not emit light, it does not reflect light, and it doesn't even absorb light to cast a faint shadow. It is truly, fundamentally invisible to our entire spectrum of perception. Our most advanced telescopes simply cannot see it. Because of this complete optical invisibility, we have been forced to act like cosmic detectives, inferring its presence only by observing its ghostly gravitational effects on the objects that are actually visible to us. We know dark matter is out there because we can watch it exert a massive gravitational force on visible matter, yet the substance itself remains entirely out of reach. The immense frustration of knowing something is dominating the universe without being able to touch it or see it has plagued the brightest human minds for nearly a century. The 2 leading theories attempting to explain this invisible ghost have long been theoretical entities known as WIMPs and axions, though hard evidence for either has remained painfully absent. The search had become relatively stale, a prolonged period of dead ends requiring a much-needed re-injection of energy to keep the investigation alive. But the narrative abruptly and violently changed course in November 2025 when news erupted out of the University of Tokyo. Astrophysicist Dr. Tomonori Tatani published a paper detailing a highly specific signal that had never been identified before, emanating directly from within our own Milky Way. This was not just a random anomaly, it appeared to have the exact properties of being produced by WIMPs, raising the staggering question of whether humanity had finally captured its first observational evidence of dark matter. What makes this discovery so remarkable is the extraordinary methodology behind it. Dr. Tatani did not build a massive new telescope or launch a revolutionary satellite. Instead, he took a painstaking, almost archaeological approach. In early 2024, he began diligently dredging through the enormous back catalogue of data collected by the Fermi telescope. The Fermi telescope is an incredible piece of astronomical hardware that was originally designed to spot immense gamma-ray bursts originating in distant galaxies. By meticulously scraping through 15 solid years of this collected data, Tatani was hunting for a microscopic needle in an infinitely massive cosmic haystack. He intentionally blocked out the blinding gamma-ray rich centre of our galaxy, knowing that the dense cluster of chaotic energy would immediately drown out any subtle signals. With incredible diligence, he systematically removed all the known astrophysical producers of gamma rays from the background, muting the deafening noise of hot accretion disks around black holes and the violent death throes of dying stars, filtering the data source by agonizing source. What remained after this exhaustive, targeted filtration process has completely floored the scientific community. Emerging from the absolute darkness of the clean data was a unique, unmistakable pattern of gamma rays. These ghostly emissions perfectly mapped onto the precise, ghostly shape of the Milky Way's predicted dark matter halo. This geographic detail is absolutely crucial. When we observe the movement of stars and gas around our galaxy, it indicates that dark matter is not concentrated in a flat galactic plane like regular visible matter. Instead, it extends far out and completely surrounds the Milky Way in a massive, invisible spherical structure termed the halo. Dr. Tatani's filtered gamma-ray signal perfectly inhabited this exact spherical geography, but the research took the revelation a monumental step further. Not only did these gamma rays populate the correct shape and structure to be the elusive halo, but their specific energy spectrum perfectly aligned with the theoretical fallout of WIMP activity. For the very first time in human history, we were no longer just tracking the gravitational wake of dark matter, we were potentially staring directly at its energetic fingerprint. If this gamma-ray signal truly originates from the invisible framework holding our universe together, this single observation has undoubtedly changed the face of physics forever. To truly grasp the magnitude of the signal detected in Tokyo, we have to rewind the clock and return to the very genesis of this cosmic cold case. The year is 1933. The scientific world was still reeling from a series of absolute paradigm shifts that had completely rewritten humanity's place in the cosmos. Just a few years prior, Edwin Hubble had shattered the prevailing belief that the Milky Way was the entirety of existence, definitively proving that our universe was vast, dynamic, and actively expanding. At the epicenter of this astronomical revolution was the California Institute of Technology, a beacon for the greatest minds of the generation. Walking its halls was a brilliantly eccentric 35-year-old Swiss astronomer named Fritz Zwicky. Zwicky was far from your conventional observer of the heavens. He had originally begun his tenure at Caltech, buried in the microscopic world, part of a research group meticulously studying the incredibly complex physics of crystal structures. But the tantalizing mysteries of the newly expanded cosmos proved far too powerful to resist, quickly sweeping him out of the laboratory and into the exciting, newly emerging field of cosmology. Zwicky was a man whose mind operated on a fundamentally different frequency. He possessed an incredibly abrasive, eccentric personality that famously put him at odds with many of his peers, but his sheer genius was entirely undeniable. It was a trait that allowed him to conceptualize revolutionary ideas that others couldn't even begin to fathom. It was Zwicky's relentless, visionary research into the origins of cosmic rays that ultimately led him to conceptualize and officially coin the term supernova, permanently altering our understanding of violent stellar death. Over the span of his prolific career, he would go on to meticulously catalogue tens of thousands of individual galaxies and publish hundreds of academic papers on a remarkably wide array of astronomical subjects. But for all of his groundbreaking contributions to astrophysics, his ultimate legacy, the one that would immortalise him forever as the undisputed father of dark matter, began with what initially appeared to be a completely impossible mathematical error. Zwicky found himself perched at the helm of the legendary Mount Wilson telescope, the exact same colossal state-of-the-art instrument that Edwin Hubble had used to literally redefine the scale of the universe. Zwicky was conducting a painstaking survey of the night sky, specifically zeroing in on a dense, chaotic patch of space located in the Coma Berenices constellation, situated near the Milky Way's galactic North Pole. This region was home to the Coma Cluster, a massive gravitational gathering of galaxies swarming together in the dark. He wasn't just capturing simple photographs of this distant cosmic city, he was meticulously measuring a phenomenon known as redshift. Redshift acts as an ingenious cosmic speedometer for astronomers. As light from a distant moving object travels across the expanding fabric of the universe to reach the observer, the light waves are physically stretched out on their incredibly long journey. The more the universe stretches this light, the longer its wavelength becomes, causing the light to appear redder and redder to our delicate instruments. By analysing exactly how red this ancient light appears, astronomers can precisely calculate that the source is moving away from us and determine exactly how incredibly fast it is travelling. Sitting alone at his desk with the raw observational data from Mount Wilson, Zwicky began to calculate the relative velocities of the chaotic galaxies within this massive cluster. He focused his intense attention on the difference in speed between 8 specific galaxies. As the numbers materialized on the page, the results were not just surprising, they completely broke the commonly accepted laws of physics. The data explicitly indicated a velocity difference of more than 2,000 kilometers per second. These unimaginably massive galactic structures were whipping around each other at speeds that absolutely defied all scientific logic. At these blistering, chaotic velocities, the entire Coma cluster should have been violently, undeniably unstable. The galaxies were moving so incredibly fast that their kinetic energy should have easily overcome the gravitational pull holding them together, violently ripping the entire cluster limb from limb and scattering the individual galaxies into the cold, empty void of deep space long ago. And yet, when Zwicky looked through the heavy eyepiece of the Mount Wilson telescope, the cluster was perfectly intact, suspended peacefully and beautifully in the dark. How could what he was witnessing with his very own eyes be reconciled with the catastrophic figures glaring up at him from the page? He realised, with a creeping sense of awe, that there was a massive, fundamental piece of the cosmic puzzle missing. Zwicky painstakingly calculated the total mass of the Coma cluster by tallying up all the light-emitting matter he could possibly observe. He accounted for the brilliant, burning stars and the massive clouds of swirling interstellar gas. The results of his calculations were entirely staggering. The combined gravitational pull of all the visible stars and gas in the cluster was nowhere near strong enough to stop these fiercely speeding galaxies from escaping one another's orbit. In fact, it wasn't even close. He mathematically proved that in order for the Coma cluster to maintain its cohesive structure and not violently tear itself apart, the system required roughly 10 times more mass than what his instruments had observed. Over 90% of the cluster was simply missing from view. It was a terrifying and profound realization. The brilliant stars and glowing galaxies that humanity had always assumed made up the entirety of the universe were nothing more than a superficial illusion, a thin coat of luminous paint obscuring a much more massive, invisible reality. Zwicky concluded that something completely hidden from view had to be at work. There had to be an invisible anchor, an undetectable, immense substance lurking deep within the cluster, generating an overwhelmingly powerful gravitational web that locked these speeding galaxies into their impossibly fast orbits. Because this elusive substance completely evaded the gaze of our most powerful optical instruments, casting no shadow and reflecting no glow, he gave it a name that has continued to plague cosmologists since that fateful study over 90 years ago: dark matter. With a few scribbled calculations, Zwicky had unknowingly opened a door to a shadow universe, one that would completely defy explanation for the next century, driving generation after generation of physicists to the absolute brink in their desperate pursuit to finally bring it into the light. For decades after Fritz Zwicky's startling observations of the Coma cluster, his terrifying proposition of an invisible cosmic anchor was largely treated as a mathematical anomaly rather than a fundamental truth of nature. The scientific establishment simply wasn't ready to accept that the vast majority of the universe was entirely hidden from their telescopes. The idea languished in the academic shadows, an unsolved quirk of astrophysics, until the narrative shifted dramatically in the 1970s. The true paradigm shift did not come from a massive multi-million-dollar international collaboration, but rather from the quiet, relentless dedication of a prolific researcher named Vera Rubin. While Zwicky had looked at the macro scale, measuring the chaotic, high-speed movement of entire galaxies whipping around each other in distant clusters, Rubin decided to focus her attention inward. She wanted to understand the internal mechanics of individual galaxies, probing the deep structural secrets of how these colossal islands of stars actually hold themselves together. To appreciate the magnitude of what Rubin was about to uncover, you have to visualize the fundamental architecture of a grand design spiral galaxy. Our own home, the Milky Way, is exactly this type of galaxy, characterized by being remarkably flat and incredibly wide. Think of it like a glowing cosmic record spinning in the dark. The gravitational geography of our galaxy, and others like it, dictates that the vast majority of all the visible matter is densely concentrated right in the flat galactic plane. From the sweeping outer tendrils of the delicate spiral arms all the way to the densely packed chaotic galactic centre, this flat disk contains all manner of stars, swirling gas, alien planets, and the colossal behemoth that anchors it all, our supermassive black hole, Sagittarius A. Because almost all the light-emitting mass we can see is crammed into this relatively thin spinning plane, all of our classical models of physics demanded that the galaxy should rotate in a very specific way. Just like planets orbiting the Sun in our solar system, the stars clustered near the massive heavy centre of the galaxy should be moving incredibly fast, while the lonely stars located out in the distant, wispy edges of the spiral arms should be moving much slower. This is exactly what Vera Rubin set out to measure in the 1970s. Over years of painstaking solitary observation, she meticulously categorized the velocities of individual star populations, mapping the rotational speeds of over 60 different galaxies. But as the data poured in, galaxy after galaxy, a chilling and completely uniform pattern began to emerge. The stars at the outermost edges of these galaxies were not slowing down at all. Instead, they were hurtling through space at absolutely blistering speeds, matching the ferocious velocity of the stars near the densely packed galactic core. Based on the amount of visible, glowing matter, contained within these galaxies, this was mathematically impossible. Moving at those extreme speeds, the outer stars should have easily broken free from the galaxy's gravitational grip, violently flinging themselves out into the empty, freezing void of intergalactic space. And yet, the delicate spiral arms remained perfectly intact, gracefully spinning in the dark. Rubin had stumbled upon a cosmic truth that was impossible to ignore. The only physical way these galaxies could hold on to their speeding, outermost stars, was if they contained a staggering amount of invisible mass exerting a monumental gravitational grip. Zwicky's dark matter wasn't just an isolated phenomenon occurring in strange distant clusters, it was intimately woven into the very fabric of over 60 individual galaxies Rubin observed, and undoubtedly countless more. It was Vera Rubin's prolific, undeniable work categorizing these bizarre velocity effects that dragged dark matter out of the fringes of science fiction and forced the scientific community to give it serious consideration for the very first time. She provided the pivotal turning point, definitively convincing an entire generation of skeptical physicists that dark matter was absolutely real and undeniably a valuable thing to study. But Rubin's revolutionary data revealed an even deeper, more profound mystery about the nature of this invisible substance, a geographic revelation that fundamentally changes how we view our place in the cosmos. Because the outer stars of these galaxies were moving so impossibly fast, Rubin and her contemporaries realized that the missing mass holding them in place could not possibly be distributed in the same way as regular matter. When we observe the movement of stars and gas around the galaxy, the gravitational math explicitly indicates that dark matter has an entirely different shape. It is not stubbornly concentrated in the flat spinning galactic plane alongside the visible stars, planets and black holes. If it were, the gravitational forces simply wouldn't add up to explain the blistering speed of the outer spiral arms. Instead, the data revealed something breathtaking. The dark matter extends far beyond the visible boundaries of the Milky Way, forming a colossal, invisible, spherical structure that completely engulfs our entire galaxy. This immense, invisible sphere is termed the halo. We are not merely riding on a flat disk of stars. Our entire Milky Way galaxy is suspended deep within the core of a titanic, invisible sphere of dark matter. This halo is the silent, unseen scaffold that binds our galactic home together, and for decades its precise shape remained a purely mathematical ghost, inferred only by gravity. It was a map of the invisible, drawn by measuring the things we could see. And it is exactly this massive spherical halo that would, half a century later, become the staging ground for Dr. Tatani's explosive hunt for gamma rays, setting the trap to finally catch the universe's ultimate ghost. 4. With Vera Rubin's colossal, spherical halo definitively mapped in the darkness, the terrifying reality of our cosmic situation finally set in for the scientific community. We were entirely engulfed by a massive, invisible bubble of enormous weight, completely at the mercy of its overwhelming gravitational tide. But establishing the geographic existence of this dark halo immediately spawned a far more complex, maddening question that would consume theoretical physicists for decades. What exactly is this invisible architecture actually made of? To answer that profound mystery, scientists had to temporarily look away from the towering macroscopic structures of swirling galaxies and dive deep down into the microscopic quantum realm. For decades, humanity's absolute best explanation for the fundamental building blocks of reality has been an incredibly robust framework known as the Standard Model of particle physics. You can think of the Standard Model as the ultimate cosmic recipe book. It meticulously categorizes every single known particle in existence, from the quarks that bind together to form the protons in your body, to the electrons that power our modern civilization, to the photons that deliver brilliant light from the sun to your eyes. It is arguably the most successful, rigorously tested scientific theory in human history. Yet, For all of its staggering mathematical beauty and predictive power, the Standard Model harbours a dark, catastrophic secret. It only explains the ingredients for regular, visible matter. It completely and utterly fails to account for the remaining 80% of the universe's mass. According to our most flawless scientific recipe book, the dark matter that anchors our very existence simply should not be there. Faced with this glaring fundamental hole in our understanding of reality, theoretical physicists realized that the Standard Model was not the complete picture. It was merely half of a much larger equation. They realized they needed a missing link, something that could seamlessly bridge the gap between the visible matter we understand and the invisible mass we can only feel. To balance the fragile mathematics of the cosmos, they proposed a radical, mathematically beautiful extension to the Standard Model. They called this framework supersymmetry. This isn't just a minor tweak to a few equations. Supersymmetry suggests that our universe possesses a hidden structural mirror symmetry built into its very fabric. It proposes that for every single known visible particle in the Standard Model, there exists a heavier, undiscovered superpartner lurking just out of sight in the quantum shadows. If you have a regular lightweight electron buzzing around an atom, supersymmetry dictates there must be a heavy, invisible counterpart acting as its cosmic mirror image. This profound theory was originally designed to solve highly obscure quantum math problems, specifically preventing the mathematical equations governing particle mass from spiraling into infinity. But this theoretical mirror universe of heavy, invisible particles inadvertently provided physicists with exactly what they were desperately searching for: a perfect, mathematically sound hiding place for dark matter. Out of the dizzying, complex mathematics of this supersymmetric framework, one prime suspect rapidly emerged to take the title of the universe's invisible anchor. It was a highly specific theoretical class of superparticles collectively known as WIMPs. The acronym stands for Weakly Interacting Massive Particles, and it perfectly describes the ultimate cosmic ghost. To truly understand why WIMPs are the absolute perfect candidate for dark matter, you have to break down their very name. First, they are weakly interacting. In the harsh realm of particle physics, this means they are completely immune to the electromagnetic force. They do not emit, absorb, or reflect photons of light in any capacity. Furthermore, they entirely ignore the strong nuclear force that binds the cores of atoms together. Because they completely bypass these fundamental forces of nature that govern normal matter, a WIMP can easily pass straight through a solid brick wall, a rocky planet, or even a blazing star without colliding with a single atom. They interact with other particles so incredibly rarely that if the WIMP theory is correct, billions of these invisible ghosts are silently passing harmlessly through your body every single second, completely undetected by your nervous system or our most sensitive medical equipment. But the second part of their name is what gives them their immense cosmic power. They are massive. While they might act exactly like intangible ghosts when it comes to interacting with light and solid objects, they possess a highly significant amount of internal mass. Physicists theorize their mass to be anywhere between 10 to several thousand times heavier than a standard proton. Because they possess this physical bulk, they are permanently bound by the one universal force they absolutely cannot ignore: gravitational attraction. This incredibly unique combination of traits, being blindingly heavy yet completely invisible and physically intangible, makes WIMPs the absolute flawless culprit for the missing mass. They have the necessary dense bulk to generate the massive gravitational wells that Fritz Zwicky observed violently tearing at the Coma cluster, and they have the sheer collective weight to form the colossal, invisible spherical halos that Vera Rubin realized were clamping down on the high speed. Outer edges of spinning spiral galaxies. For decades, the entire scientific establishment confidently placed their bets on this elegant framework of supersymmetry. They built colossal, multi-billion-dollar subterranean laboratories burying massive vats of supercooled liquids deep inside abandoned mines, hoping beyond hope to catch just a single. Incredibly rare collision between a passing WIMP and a regular atom. They utilised state-of-the-art particle accelerators across the globe, slamming regular protons together at nearly the speed of light, desperately trying to artificially generate a supersymmetric particle and definitively prove the math correct. But year after year, decade after decade, the subterranean detectors remained frustratingly silent, and the particle colliders yielded nothing but empty data. The invisible mirror universe stubbornly refused to show itself. The incredibly elegant math of supersymmetry was rapidly beginning to look like a beautiful tragic dead end. The scientific community was beginning to sweat, forced to wonder if they had just spent the last 40 years relentlessly chasing a mathematical phantom. The tension was immense, and the widely accepted WIMP theory was standing precariously on a razor's edge. But physicists knew that these elusive particles harboured one final, spectacular theoretical trait, a violent, explosive loophole built into the very laws of thermodynamics. And it was exactly this explosive loophole that Dr. Tomonori Tatani would eventually exploit, peering deep into the Fermi archives to pry the universe's greatest secret violently out of the shadows. The agonizing pursuit of the invisible universe had backed the scientific establishment into a corner. If weakly interacting massive particles, or WIMPs, truly refused to reflect light and seamlessly phased through solid matter like ghosts, how could humanity possibly hope to ever observe them? The solution required a complete and radical shift in perspective. If we could not see the invisible monster directly, we would have to meticulously search for the chaotic, glowing wreckage it left behind in its wake. Physicists realized that while WIMPs might be permanently cloaked in darkness, the extreme underlying laws of quantum mechanics dictated that they possessed a fatal flaw. To understand this explosive, built-in loophole, we have to examine one of the strangest yet most fundamental rules governing the microscopic architecture of reality, the existence of antimatter. According to the flawlessly calculated standard model of particle physics, the fundamental ingredients of our reality are not unique. Every single known particle in the universe is fundamentally paired with an exact mirror opposite. This means that for every tiny piece of matter that exists, there is a counterpart waiting out there in the shadows. The familiar proton, a heavy cornerstone of the atoms that make up your body and everything around you, has a dark twin known as an antiproton. Both the standard proton and its antimatter counterpart share the exact same mass, but they possess an equal and violently opposing electric charge. The tiny negatively charged electron that surges through our wires to power modern civilization also has a twin, a positively charged particle known as a positron. It sounds entirely like the realm of science fiction, an abstract concept dreamt up to fuel the engines of starships in a blockbuster film, but antimatter is an undeniable, verifiable fact of nature. It is woven so deeply into the fabric of everyday life that you interact with it without even realizing it. In fact, antimatter is so incredibly common and mundane that a completely regular, everyday banana sitting on your kitchen counter actively emits small amounts of it into the air. However, there is a catastrophic and inescapable consequence to this mirrored existence. Normal matter and antimatter absolutely cannot peacefully coexist in the same space. When a particle is unfortunate enough to cross paths with its exact antiparticle, the result is instantaneous, incredibly violent, and completely absolute. The moment they touch, they completely cancel each other out in a brilliant, explosive flash, a highly destructive quantum process that physicists refer to as annihilation. When these two opposing particles annihilate, they do not simply vanish quietly into nothingness. The universe demands a strict accounting of their previous existence. Instead of fading away, they release a massive signature burst of pure, unadulterated radiation. To truly comprehend the sheer devastating power of this microscopic explosion, we have to turn to another brilliantly eccentric physicist whose work fundamentally altered the course of human history. Albert Einstein provided the scientific community with the ultimate decoder ring for understanding the brutal mechanics of the cosmos, his legendary equation, E = mc. This iconic string of characters profoundly revealed that mass and physical energy are not two separate, isolated concepts. Instead, they are completely interchangeable, acting as two distinct sides of the exact same cosmic coin. The violent annihilation of a particle and its antiparticle is arguably the most beautiful, terrifying, and fundamental example of Einstein's famous formula in action. In that split second of microscopic destruction, the entire physical mass of both colliding particles is flawlessly and completely converted into a brilliant flash of pure energy. This is exactly where the agonizing hunt for the elusive dark matter finally finds its observational footing. Just like the regular visible particles categorized in the Standard Model, these ghostly WIMPs are bound by the unforgiving rules of quantum annihilation. When two of these heavy, invisible particles blindly cross paths in the freezing, lightless depths of the galactic halo, they instantly annihilate one another. Because physicists theorize that WIMPs are incredibly massive, carrying a physical bulk anywhere from 10 to several thousand times the mass of a single standard proton, their sudden destruction produces a profoundly energetic explosion. The immense physical weight of the colliding WIMPs is instantaneously translated into a screaming burst of high-energy radiation, primarily exploding outward in the extreme form of photons and gamma rays. These resulting gamma rays are the absolute ultimate prize for modern astrophysicists. They are the most energetic, extreme form of light known to exist in the entire universe. While our fragile human eyes cannot see them, our advanced orbital telescopes are specifically designed to catch their blazing glow. For astronomers hunting the invisible architecture of the cosmos, these gamma rays are incredibly helpful clues. They act exactly like glowing, energetic fingerprints carelessly left behind at a massive cosmic crime scene. They definitively indicate exactly where violent, unseen activity has occurred in a dark region of the galaxy, and they clearly signpost where it may be pertinent for humanity to take a much closer look. But the sheer brilliance of this cosmic trap goes even deeper than simply spotting a random flash of energy in the dark. Because of the strict, unyielding mathematics of Einstein's equation, the energy profile of these resulting gamma rays is completely and fundamentally related to the specific mass of the original destroyed particles. This means that by meticulously capturing and measuring the exact energy signature of the gamma rays, physicists can mathematically work backward from the explosion. They can determine the precise weight of the invisible ghost that triggered the blast, flawlessly matching the specific gamma ray signature to the predicted theoretical mass of a WIMP. We no longer needed to figure out a way to catch a WIMP directly, we just needed to patiently watch the invisible dark matter halo and wait for the energetic fireworks to begin. It was a conceptually flawless plan. The invisible substance holding the Milky Way together was secretly betraying its own existence, constantly lighting up the dark matter halo with microscopic gamma-ray explosions every time these massive particles collided and annihilated. The glowing cosmic fingerprints were out there in the darkness, waiting to finally be discovered. But if these blazing gamma-ray signals were continuously erupting all around our galaxy, why hadn't we easily noticed them decades ago? The terrifying reality is that while gamma rays are the perfect fingerprint, they can also be left by a myriad of different sources. They are actively created and released in all sorts of terrifying astrophysical processes throughout the cosmos. The universe is an incredibly loud, chaotic and violent place, and finding the faint, ghostly whispers of WIMP annihilation meant staring into a blindingly bright maelstrom of cosmic noise. To finally catch the ghost, someone would have to undertake the seemingly impossible task of perfectly filtering the entire sky. The theoretical trap was perfectly set. If weakly interacting massive particles were indeed colliding and annihilating in the freezing darkness, their explosive demise would inevitably broadcast a glowing signature of gamma rays across the cosmos. But the transition from an elegant mathematical theory to a hard physical observation is rarely a straightforward journey. The agonizing problem with searching for these highly specific energetic fingerprints is that the universe is far from a quiet, sterile laboratory. It is, in reality, a deafeningly loud, unbelievably violent, and chaotic arena. To spot the incredibly faint, ghostly whisper of a microscopic dark matter collision, astronomers would first have to contend with the blinding, overwhelming roar of the cosmos itself. Gamma rays, you see, are not exclusively produced by the exotic destruction of invisible particles. They are actively forged and violently expelled in some of the most extreme, terrifying astrophysical processes known to exist. To fully grasp the sheer scale of the observational nightmare scientists faced, you have to look at the immediate geography of our own cosmic neighbourhood. Our home, the Milky Way, is a grand design spiral galaxy, stretching out incredibly flat and impossibly wide across the void. Because of this distinct flattened architecture, the vast, overwhelming majority of all visible light-emitting matter is densely concentrated right inside the spinning galactic plane. This tightly packed disk is an absolute cauldron of high-energy activity. From the sprawling, wispy outer tendrils of the spiral arms all the way down into the densely choked, chaotic galactic centre, the plane is constantly surging with extreme radiation. It is populated by the agonizing death throes of dying stars exploding as supernovae, sending massive shockwaves of energy rippling through interstellar space. It is littered with the insanely hot, swirling accretion disks that furiously orbit voracious black holes, churning out blinding amounts of radiation as they rip apart nearby matter. And anchoring the absolute centre of this chaotic maelstrom is Sagittarius A, our galaxy's own supermassive black hole, an unimaginably dense behemoth that completely dominates the gravitational landscape. Naturally, because almost all of the galaxy's extreme celestial bodies are crammed into this relatively thin spinning disk, the vast majority of the Milky Way's gamma-ray production is completely restricted to this flat plane. Looking toward the galactic centre with a gamma-ray detector is like staring directly into a blinding cosmic searchlight. The sheer volume of extreme radiation being blasted out by these conventional astrophysical sources creates a blinding, impenetrable wall of noise. Attempting to spot the delicate, subtle flash of a dark matter annihilation hidden somewhere within that raging storm is fundamentally akin to trying to hear a single pin drop in the middle of a screaming, crowded stadium. It is an observational task so overwhelmingly complex and fraught with background interference that for years it seemed practically impossible to definitively isolate a true dark matter signal. To crack this cosmic cold case, humanity desperately needed a completely new, radically different, and honestly painstaking approach. It required someone willing to undertake an almost archaeological excavation of the sky. Enter astrophysicist Dr. Tomonori Tatani from the University of Tokyo. In early 2024, Dr. Tatani did not request time on a brand new, untested piece of equipment, nor did he look for a fresh patch of empty space to observe. Instead, he realized that the answer might already be sitting right in front of us, buried deep within a mountain of forgotten data. He turned his attention to the enormous, incredibly rich back catalogue of the Fermi Telescope. The Fermi Telescope is a truly unparalleled piece of astronomical hardware that has been silently orbiting our planet, patiently and continuously watching the high-energy universe for well over a decade. It was originally designed to spot incredibly massive, catastrophic gamma-ray bursts originating from distant ancient galaxies far beyond our own. Because of its constant, unblinking vigilance, Fermi had inadvertently accumulated a staggering, comprehensive map of the gamma-ray sky. Dr. Tatani embarked on a monumental effort to systematically dredge through 15 solid years of this collected Fermi data. But his genius lay not just in the volume of data he analysed, but in the highly specific, counter-intuitive methodology he employed. Tatani fully understood that the raging maelstrom of the galactic plane was simply too loud, too chaotic, and too polluted with conventional radiation to ever yield a clean, undeniable dark matter signal. So, he made the incredibly bold, calculated decision to completely block out the blindingly bright, gamma-ray-rich centre of the Milky Way from his investigation entirely. He intentionally blinded himself to the loudest part of the galaxy, choosing instead to focus his intense scrutiny on the quieter, darker regions stretching high above and far below the flat spinning disk. This is where the true, grueling detective work began. Even outside the densely packed galactic core, the cosmic background is still littered with stray radiation. Tatani had to undertake an agonizing process of subtraction. He meticulously began to peel back the layers of the universe, carefully identifying and systematically removing every single known, conventional astrophysical producer of gamma rays from his massive dataset. It was a painstaking filtration process, silencing the data source by agonizing source. He mathematically scrubbed away the glowing remnants of ancient supernovae. He filtered out the high-energy pulses from rapidly spinning neutron stars, and he erased the ambient glow of stray cosmic rays colliding with interstellar gas. He relentlessly stripped away every shred of normal, explainable astrophysical phenomena that could possibly masquerade as the ultimate prize. The scientific community watched with bated breath as Tatani meticulously cleared the static, waiting to see what, if anything, would remain once the blinding noise of the visible universe was finally silenced. He was searching for a ghost, but he knew exactly what shape that ghost was supposed to take. Years earlier, the revolutionary work of pioneers like Vera Rubin had already established that the invisible mass anchoring our galaxy does not sit inside the flat galactic disk, but completely engulfs it in a massive spherical halo. If WIMPs were truly out there, annihilating in the dark, their gamma-ray fingerprints wouldn't be flattened along the plane, they would form a massive, glowing sphere in the sky. As the final layers of conventional radiation were stripped away from the 15 years of Fermi data, the absolute darkness of the deep universe was finally exposed, and what emerged from the shadows of that cleaned data was about to completely rock the foundations of modern physics, definitively proving that the universe had been keeping an incredibly explosive secret hidden in plain sight. When the final layers of conventional astrophysical noise were mathematically scrubbed from the 15 years of Fermi telescope data, the absolute darkness of the deep universe was finally exposed. For decades, humanity had stared into that exact same void and seen absolutely nothing but empty, freezing space. But Dr. Tomonori Tatani was no longer looking at the raw, blinding chaos of the cosmos. He was looking through a perfectly crafted, highly specific analytical lens. As the silence of the clean data settled, a faint, ghostly whisper began to emerge from the digital shadows. It wasn't a sudden, blinding flash, nor was it a dense, singular point of light. Instead, it was a vast, sprawling, and incredibly subtle pattern of gamma-ray radiation. This faint glow was suspended out in the dark, stretching high above and far below the flattened disk of our galaxy. When astrophysicists looked at the geometric distribution of this newly isolated radiation, a collective shiver went down the spine of the scientific community. The shape of this faint gamma-ray emission did not conform to the flat, spinning architecture of the Milky Way's visible stars and gas. It wasn't constrained by the chaotic gravitational pull of the galactic plane, where our massive black hole and churning solar systems reside. Instead, it formed a colossal, glowing spherical structure that completely engulfed our entire galactic home. It was a shape that had haunted the dreams of astronomers for over half a century. The incredibly unique pattern of these gamma rays flawlessly traced the exact theorized shape of the Milky Way's invisible dark matter halo. The monumental nature of this geographic match simply cannot be overstated. Ever since Vera Rubin's prolific research in the 1970s definitively mapped the gravitational influence of dark matter, scientists knew that the missing mass had to be concentrated in a massive spherical bubble surrounding galaxies like our own. For 50 years, this halo had remained a purely mathematical construct, a terrifyingly massive ghost that we could only feel pulling on the outer edges of the spiral arms. We had completely accepted that we would never actually see it directly. Yet here, emerging from Dr. Tatani's meticulously filtered dataset, was a glowing, energetic map that perfectly inhabited that exact spherical geography. It was as if the invisible scaffolding of the universe had suddenly been painted with a faint radioactive dye, allowing us to trace its colossal structure against the absolute blackness of the void. But the staggering revelations hidden within the Tokyo signal did not stop at its physical shape. While the spherical geometry strongly suggested they were looking at the dark matter halo, the true, undeniable smoking gun lay buried deep within the specific microscopic properties of the light itself. Remember, the entire premise of hunting for these gamma rays relied on the explosive, built-in loophole of quantum annihilation. When two invisible, weakly interacting massive particles blindly collide in the dark, their immense physical mass is instantaneously converted into a brilliant burst of pure energy, fundamentally dictated by Albert Einstein's famous equation E=mc. Because energy and mass are strictly interchangeable, the resulting gamma rays act like an incredibly precise cosmic scale. By measuring the exact energy profile of the burst, physicists can flawlessly calculate the specific mass of the invisible particles that were destroyed to create it. When Dr. Tatani's team analysed the energetic fingerprint of this vast spherical gamma-ray glow, the results completely defied all sceptical expectations. The energy spectrum of the radiation was not a chaotic, random assortment of frequencies. It was highly uniform, specifically peaking at a distinct, measurable energy level of exactly 20 gigaelectron volts. In the realm of high-energy particle physics, 20 gigaelectron volts is not just an arbitrary number. It is a highly specific, monumental figure that sits absolutely perfectly within the tightly constrained theoretical mass range required to be the direct result of WIMP annihilation. For decades, teams at massive multi-billion-dollar subterranean particle accelerators around the entire world had been tirelessly working to constrain the theoretical properties of these invisible superparticles. While they hadn't been able to artificially create one, their complex mathematical models had established a distinct, acceptable window for how heavy a WIMP should be, ranging between 10 to thousands of times the mass of a standard proton. The 20 giga-electron-volt peak, discovered emanating from the Milky Way's halo, landed squarely inside that fiercely debated target zone. The sheer astronomical stakes of this single observation were absolutely paralysing. This was no longer just a fascinating gravitational anomaly or a clever trick of the light. We were looking at a signal that possessed both the precise macroscopic shape of the galactic dark matter halo and the exact microscopic energy signature of WIMP destruction. It successfully bridged the incomprehensible, massive gap between the towering, ancient structures of cosmology and the invisible, elusive mechanics of particle physics. For the very first time in human history, it appeared we had transcended the limitations of our optical instruments and captured the universe's ultimate ghost in the act of revealing itself. If this 20 giga-electron-volt signal is truly the energetic fallout of WIMPs relentlessly colliding in the freezing depths of the halo, its discovery will permanently alter the trajectory of human knowledge. It means the elusive mirror universe of supersymmetry is not just a beautiful mathematical fantasy, but a hard physical reality. It means that the invisible substance that birthed the very first baby stars, sculpted the colossal galaxy clusters, and continues to hold our very own solar system in its unyielding gravitational grip, has finally been brought into the light. The 90-year-old cold case opened by Fritz Zwicky, a mystery that drove generations of the world's most brilliant minds to the absolute brink, appeared to be definitively solved by a faint glowing whisper in the data. The scientific community was ready to celebrate a discovery likened in significance to Darwin's theory of evolution, prepared to completely rewrite the textbooks and close the book on the dark matter conundrum forever. But the universe, it seems, fiercely guards its deepest secrets, because when physicists began to look closer at the sheer strength of the 20 giga-electron-volt glow, the initial overwhelming triumph rapidly dissolved into a creeping, terrifying sense of dread. The celebration was brought to an abrupt, violent halt as a massive catastrophic paradox emerged from the numbers, threatening to tear our understanding of the cosmos completely apart. The 20 giga-electron-volt signal radiating from the darkness of the Milky Way's halo was supposed to be the ultimate, indisputable triumph of modern astronomy. It was the exact energetic fingerprint scientists had been violently chasing for nearly a century. But science is rarely that cooperative, and the universe has a terrifying habit of pulling the rug out from under our greatest revelations. When Dr. Tatani's team stopped looking at just the specific microscopic energy of the gamma rays and began measuring the macroscopic shear volume and intensity of the signal, a catastrophic problem emerged. The spectral glow emanating from the invisible dark matter halo was undeniably brilliant, but it was fundamentally too bright. To truly understand why the extreme brightness of this signal threatens to completely dismantle our fundamental understanding of the cosmos, we have to temporarily leave the modern Milky Way and journey all the way back to the very beginning of time itself. WIMPs are not just random floating microscopic space rocks, they are ancient fundamental relics that were violently forged in the unimaginably extreme conditions of the Big Bang. In the first microscopic fraction of a second of the universe's existence, the cosmos was a blinding, infinitely dense, and incredibly hot soup of raw energy. The conditions were so absolutely extreme that energy and physical mass were frantically swapping back and forth, spontaneously creating and destroying particles in a chaotic, roaring quantum storm. But this superheated chaos could not last. As the infant universe rapidly began to expand outward, it aggressively and continuously cooled down. This rapid cooling process effectively acted like a colossal cosmic freezer. It permanently halted the spontaneous creation of these heavy particles, permanently locking the surviving population of WIMPs into existence. Physicists refer to this surviving ancient population as a relic density. By rigorously studying the mechanics of the early universe, our current flawlessly tested models of particle physics give us a very strict, mathematically sound estimate of exactly how many of these WIMP relics we expect to be populating the universe today. But we do not just have to rely on complex theoretical math scribbled on a chalkboard to know this precise number. We actually have physical, undeniable and observational proof permanently burnt into the sky. By peering into the deepest, most silent reaches of the cosmos, astronomers can directly observe the cosmic microwave background. This faint, invisible ambient radiation is the literal fading afterglow of the Big Bang itself. It essentially acts as a perfectly preserved ancient baby picture of the newly formed universe. By meticulously capturing and studying the microscopic temperature fluctuations hidden deep within this ancient microwave light, cosmologists have been able to perfectly map the structural DNA of the early universe. The cosmic microwave background serves as the ultimate cosmic ledger. It tells us exactly how much regular, visible matter was successfully created, and crucially, it dictates the absolute, unyielding maximum number of dark matter particles that are physically allowed to exist in the cosmos today. This is exactly where Dr. Tatani's monumental gamma-ray discovery violently smashes headfirst into a towering brick wall of physics. For the Milky Way's invisible dark matter halo to be glowing as intensely as the Tokyo signal strongly indicates, it requires a staggering, relentless amount of violent quantum annihilation. And to mathematically achieve that sheer, blinding volume of explosive particle collisions, the population density of WIMPs completely swarming around our galaxy must be unbelievably high. The halo would have to be absolutely choked with these invisible particles to generate so many constant microscopic explosions. But when astrophysicists cross-reference the required massive WIMP density for Tatani's glowing signal against the hard, unyielding data meticulously collected from the cosmic microwave background, the numbers do not match. In fact, they are catastrophically misaligned. The glowing gamma-ray signal appears to be fueled by a significantly denser collection of WIMPs than our flawlessly tested models of the early universe dictate should even be mathematically possible. The existential implications of this massive density paradox are absolutely terrifying for the entire scientific establishment. We are suddenly and violently trapped in a cosmic catch-22. If this 20 giga-electron-volt gamma-ray burst is truly the undisputed holy grail signature of WIMP annihilation, then it means humanity is entire. Foundational understanding of how the universe was actually born is fundamentally broken. If that staggering, overwhelmingly dense population of WIMPs truly exists out there in the galactic halo, then our pristine models of the Big Bang and the ancient universe are utterly wrong. It would suggest that the microscopic particle interactions that govern the absolute dawn of time were vastly, terrifyingly different than we ever imagined. It introduces the horrifying possibility that there is a completely unknown, invisible mechanism actively creating new dark matter particles in the void, completely defying the established laws of thermodynamics long after the universe cooled down. The scientific community is now frantically scrambling to untangle these massive contradictory snags, desperately trying to construct a new mathematical bridge that can somehow reconcile the blinding, chaotic intensity of the Tokyo signal with the hard, unforgiving limits of the ancient universe. They simply cannot afford to ignore this monumental lead, as WIMP annihilation remains arguably the absolute strongest contender for what this mysterious, perfectly shaped gamma-ray signal could possibly be. But the sheer, mind-bending impossibility of the density math has cast a long, chilling shadow over the initial celebration. The agonizing reality is beginning to set in for physicists across the globe. What if the incredibly perfect 20 giga-electron volt signal is nothing more than a cruel, highly orchestrated cosmic mirage? If the overwhelming density of WIMPs required to physically fuel that glow simply cannot exist without breaking the fundamental laws of the universe, then we are forcefully backed into a corner, forced to ask a truly devastating question. What if the universe's ultimate ghost isn't a WIMP at all? The crushing weight of the density paradox has sent an icy, undeniable chill through the halls of modern astrophysics. The tantalizing 20 giga-electron volt signal, initially hailed as the ultimate triumph of human observation, now threatens to completely unravel our foundational understanding of the cosmos if WIMPs are indeed the culprit. The terrifying density required to fuel such a brilliant gamma-ray glow explicitly breaks our perfectly calculated models of the early universe. But what if the cosmic model isn't the thing that's fundamentally broken? What if the universe is simply playing a deeply cruel, incredibly complex trick on our most brilliant minds? In the frenzied, chaotic aftermath of Dr. Tatani's massive announcement, a powerful, sobering voice of reason emerged from the very top of the scientific establishment, urging the world to immediately pull back from the brink of premature celebration. Professor Carlos Frenk, a lifetime researcher who has spent his entire career intimately mapping the invisible mechanics of the cosmos, stepped forward to issue a profound and sobering warning. As one of the original pioneering architects of the leading cold dark matter theory, the very mathematical framework that originally birthed the WIMP model, Professor Frenk intimately understands the catastrophic stakes of this discovery. He explicitly likened finding the true, verified source of dark matter to a scientific paradigm shift on par with Charles Darwin's theory of evolution. It is a foundational, earth-shattering truth that will fundamentally rewrite the entire history of our existence, permanently altering how humanity views its place in the void. Because of that immense world-altering significance, he warned that it is absolutely not a claim you can make unless you are undeniably, unequivocally, and flawlessly sure. And right now, the agonizing truth paralyzing the scientific community is that we are simply not sure. The terrifying alternative to the density paradox is the very real haunting possibility that the stunning 20 giga electron volt signal is a monumental false positive. The universe is an incredibly chaotic, noisy arena overflowing with violent, high-energy phenomena we have yet to fully catalogue or even mathematically comprehend. It is entirely possible that this perfectly shaped, glowing halo of gamma rays isn't the explosive death of invisible dark matter particles at all. Instead, it could be the energetic exhaust of an entirely undiscovered population of rapidly spinning pulsars, or a strange, unknown astrophysical process occurring deep within the cosmic background that simply happens to perfectly mimic the WIMP signature. If Tatani's glowing signal is eventually proven to be nothing more than a highly orchestrated masquerading illusion, it doesn't just send cosmologists back to the drawing board, it effectively sounds the death knell for the entire WIMP theory. After 40 agonizing years of constructing empty underground vats, building silent particle colliders, and now chasing a potentially shattered gamma-ray dream, physicists would be violently forced to confront the horrifying reality that they have spent half a century relentlessly hunting the exact wrong ghost. If the massive, heavy WIMP is truly a definitive dead end, where does humanity turn to solve Fritz Zwicky's 90-year-old cold case? The answer requires a radical, dizzying departure from everything we thought we knew about the invisible universe, dragging a long-forgotten cosmic suspect out from the shadows. From the very beginning of this monumental manhunt, there have always been two distinct leading theories dominating the scientific conversation: WIMPs and axions. For decades, the axion has been the perpetual, quiet runner-up, languishing deep in the colossal theoretical shadow of the WIMP, because it entirely lacked the elegant, explosive loophole of quantum annihilation. But with the WIMP theory now teetering precariously on the absolute edge of a massive density crisis, the axion is experiencing a violent, sudden resurrection in the minds of theoretical physicists across the globe. If dark matter isn't a massive collection of unimaginably heavy colliding microscopic boulders, it might be the exact, terrifying opposite. To truly comprehend the sheer strangeness of the axion alternative, you have to completely invert your fundamental understanding of mass. While WIMPs are theoretically predicted to be incredibly massive, heavy behemoths, weighing anywhere from 10 to thousands of times more than a standard proton, axions are theoretically almost completely weightless. If they exist in the darkness, they are so unbelievably, staggeringly light that it would take trillions upon trillions of them just to equal the mass of a single tiny electron. They were not born from the beautiful, mathematically symmetrical mirror universe of supersymmetry. Instead, they were originally hypothesized by desperate physicists in the 1970s to solve a completely different, highly obscure mathematical error regarding the strong nuclear force that binds the microscopic cores of atoms together. But just like the WIMP, scientists quickly realized that if these bizarre ultralight particles were forged in the chaotic, superheated fires of the Big Bang, they would possess the exact right properties to act as the universe's invisible anchor. However, because they are so impossibly, unimaginably light, a dark matter halo constructed out of axions wouldn't behave anything like a halo made of WIMPs. Instead of acting like a violent swarm of heavy individual particles crashing into one another and exploding in the dark, an axion halo would act far more like a sprawling, invisible quantum ocean. Trillions of these weightless, ghostly particles would seamlessly merge together, flowing silently through the spinning spiral arms of the Milky Way as a continuous, sweeping, invisible wave. Because of their microscopic mass, they wouldn't violently annihilate to create blazing 20 giga electron volt gamma ray bursts. In fact, if the axion theory is the true reality of our cosmos, then Dr. Tatani's signal is undeniably 100% a false positive, because axions fundamentally lack the sheer physical mass required to produce such a highly energetic explosion. Instead, their interaction with the visible universe would be incredibly subtle, almost undetectable. Theorists believe that when an axion wave passes through an incredibly intense magnetic field, like the twisting, violent magnetic lines generated by a rapidly spinning neutron star, it has a tiny, microscopic chance of spontaneously converting into a single, highly specific photon of light. The scientific community is now standing completely paralyzed at a terrifying existential crossroads. The absolute stakes of human knowledge have never been higher. Down one path lies the WIMP, demanding that we completely rewrite the fundamental laws of the Big Bang to forcefully explain the blinding density of the Tokyo signal. Down the other path lies the axion, a weightless quantum wave that aggressively demands we completely abandon 40 years of heavily funded research, scrap our multi-billion-dollar underground detectors, and entirely change the way we hunt for the invisible universe. We are violently caught in a desperate, high-stakes tug-of-war between two vastly different versions of reality, and theoretical mathematics alone is no longer enough to break the brutal stalemate. The era of staring at chalkboards and blindly hoping for a lucky microscopic collision has violently ended. To untangle these massive contradictory snags and definitively answer the ultimate question of our existence, we need a relentless, unprecedented flood of new, undeniable observational data. We need to map the invisible architecture of the cosmos with a staggering level of precision that humanity has never even attempted before. And deep in the freezing, high-altitude mountains of Chile, a colossal mechanical eye is just waking up, preparing to unleash exactly that. The excruciating stalemate between the towering, heavy WIMP and the invisible, ghostly Axion has forcefully dragged the scientific community to a profound realization. Theoretical mathematics and microscopic isolated data anomalies alone can no longer break the cosmic deadlock. To truly understand whether our universe is anchored by unimaginably heavy microscopic boulders violently annihilating in the void, or a sprawling weightless quantum ocean silently flowing through the spiral arms, we need to completely abandon our chalkboards and look back up at the night sky. But the observational tools of the past are simply no longer powerful enough to pierce the thick, impenetrable veil of the dark universe. To finally untangle the massive contradictory snags introduced by Dr. Tatani's explosive gamma-ray signal, humanity desperately needs a mechanical eye capable of capturing the cosmos with a sheer, terrifying scale of precision that we have never even dared to attempt. And right now, perched high up in the freezing remote mountains of Chile, exactly that kind of colossal machine has finally awakened. The latest and arguably most powerful investigator to arrive on this cosmic crime scene is the brand new Vera Rubin Observatory. It is incredibly fitting and almost poetic that this monumental facility bears the name of the prolific researcher who, back in the 1970s, definitively proved that an invisible substance was violently manipulating the velocity of individual star populations across more than 60 different galaxies. Vera Rubin's painstaking solitary work mapping the invisible halo was the absolute pivotal turning point that dragged dark matter out of the realm of mathematical anomaly, officially convincing the global scientific establishment that it was a profound physical reality demanding serious investigation. Now, her namesake observatory is preparing to finally finish the incredible work she started half a century ago. Having officially come online in June 2025, the entire astronomical community has been waiting with bated breath for the facility to release its very first massive datasets, which are eagerly expected for release in 2026. But this groundbreaking facility is not simply looking at one isolated galaxy or staring intently at a single distant cluster of stars. Instead, it is undertaking a staggering, relentless nightly mission of unprecedented scale. As the sun sets over the Chilean peaks, the observatory's massive mechanical eye opens to the heavens and begins rapidly capturing hundreds of incredibly detailed images, meticulously sweeping across the entirety of the southern hemisphere's sky night after night. The sheer, terrifying volume of raw digital information this single observatory is aggressively dragging down from the heavens is almost impossible for the human brain to comprehend. Every single night it operates, it captures an astounding 20 terabytes of raw data. To put that immense digital weight into a more physical perspective, it is the exact storage equivalent of completely filling up 78 standard iPhone 17s every single evening, just from capturing the faint ancient light of the stars. Over the course of its initial 10-year observing schedule, this relentless nightly sweep is expected to culminate in a monstrous, unprecedented database totaling more than 60 petabytes or 60 million gigabytes of raw cosmic imagery. This 60 petabyte future is not just about cataloguing the visible universe, it is a highly calculated, monstrous effort specifically designed to reveal the deepest, most fiercely guarded secrets of our universe, hoping to uncover bizarre gravitational phenomena and objects never before seen in our night sky. By meticulously mapping the exact positions and subtle distortions of billions of distant galaxies, scientists will essentially use this mountain of data to trace the precise physical shape of the dark matter web stretching across the entire cosmos. If this staggering volume of imagery reveals that the invisible universe forms tight, incredibly dense clumps of gravitational gravity, the heavy WIMP theory might violently rise from the ashes of the density paradox. But if the 60 petabytes of data reveal a perfectly smooth, flowing distribution of mass, the invisible quantum wave of the axion will undeniably take the throne. The Vera Rubin Observatory is merely the terrifyingly powerful spearhead of a massive, globally coordinated revolution. From the dizzying high-altitude peaks of Chile to the silent, frozen depths of underground laboratories in South Dakota and Switzerland, all the way up to advanced satellites silently patrolling in low Earth orbit. The most brilliant human minds on the planet are actively on the case. We are aggressively attacking the mystery from every conceivable angle, utilizing the vast macroscopic expanse of general relativity alongside the fantastical microscopic quantum world of particle physics. The ultimate goal is to bridge the most massive gap in human knowledge, violently unifying the two fields to definitively solve the ultimate cosmic cold case. And the philosophical stakes for solving this mystery truly could not be any higher. This elusive, invisible substance that entirely refuses to interact with our light fundamentally makes up more than 80% of all the known matter in existence. We, the glowing stars, the swirling gas clouds, and the brilliant galaxies are the absolute minority in our own universe. Dark matter is the literal fabric of our existence. Its overwhelming gravitational influence directly enabled the chaotic formation of the very first baby stars and ancient galaxies at the dawn of time. It has silently and relentlessly sculpted the architecture of our cosmos, forcing the universe to look the exact way it does today. And make no mistake, it is the unrelenting, invisible gravitational grip of this dark substance that will absolutely dictate the ultimate fate of our future. Whether the invisible scaffolding of reality is built upon the explosive, elusive WIMP or a completely different quantum phantom entirely, we are standing at the absolute precipice of a new era of understanding. The search for dark matter had been a relatively stale, frustrating pursuit for years, but Dr. Tatani's incredible gamma-ray signal has injected a brilliant, violently needed rush of energy back into the field. It is the most exciting development in the observational search for dark matter in decades. We have never seen dark matter until now. And as the immense 60 petabyte floodgates of the Vera Rubin Observatory finally prepare to open, humanity is undeniably perched on the cusp of a dark revolution. It is an absolute thrill to watch it unfold as we finally prepare to stare directly into the dark and watch the true nature of our universe stare back.